Hi, this is the June 2024 net paper of physical sciences. I'm doing part A questions 1 to 5 in this video. A large number of birds, half of which belong to species A and the other half to species B, rest on a tree where they are distributed randomly across the branches. In a random sample of 5 birds from the tree, what is the probability that at least one is from species A? Okay. Now, had they not used the word at least, what is the probability that one is from species A? Yeah. The other half to species B. In a random sample of 5 birds from the tree, what is the probability that one is from species A? So, see, out here, they've given us the probability that half is from species A and half is from species B. Yeah. Which means that the probability that if I were to consider one of the 5 birds is from species A, then in that case, my answer would be in a random sample of 5 birds, exactly one is from species A, the remaining are from not A, meaning from B. So my answer would have been the number of ways to arrange these 5 letters. So imagine this is B, 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 B. So 1A and 4Bs. The arrangement of such 5 letters with B being identical is 5 factorial by 4 factorial. And then it would be for each of them, it will be half, 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 because B is also half and A is also half. It says a half of which. So it'll be half to the power 5. That would be my answer. But then that word at least changes everything, right? So one way to solve this question is we consider one is when exactly one is from A. Yeah. Now at least one, meaning one or more than one, meaning it could be all 5. So I'll consider now case number 2 where 2 are from species A and 3 are not. And then I would consider 3 like that. And then 4 and 1 not. And then 5 where all of them are from species A. But then a better way to solve this question, because probability of this is also be first one is this. Then there'll be a second one, and then third one, and then fourth one, and then fifth one, and then we have to add them all up. And that would be my answer. So a better way to solve this question is find out the probability that none of them are from species A. So none of them are from species A would mean all 5 are not from species A. And there's only one such probability, 5 factorial by 5 factorial. Arrangement of letters where 5 letters are repeating. So first of all, count the number of letters, so 5 factorial. Divided by 5 factorial because all the letters are repeating, meaning all are duplicates. Into half into half into half 5 times. So my answer is basically 1 by 32. For none of them being from species A. Now if I subtract that 1 by 32 from the whole 100%, then I would get an outcome of 31 by 32, which tells me that at least one is from species A, meaning this entire 5 lot would simply mean this as an answer. You can check it out. So I'll just give you the breakup out here. It'll be 5 factorial by 3 factorial into 2 factorial, because there are these 2 identical and these 3 identical. So like that, half to the power 5. 5 factorial by 4 factorial into half to the power 5. You know, so yeah, so this one will be, see, this is for this one, this is for this one. Yeah, this is remaining. So this is also the one. So you can count it again. So 5 factorial by 3 factorial, 2 factorial, half to the power 5. So 1, 2, 3, 4. And for this one, it is that one. So 5 factorial by 5 factorial into half to the power 5. Now, when you add all of them, it should equate to 31 by 32. Now, if you use your calculator and if you check for 31 by 32, you should get the answer. It's 0.00. Now, the question is, what is the 31 by 32? 0.967, 96875. Okay, question, but a tricky question. Very good question, in fact. So that is your answer, by the way. Moving on to question number 2. Okay, that is challenging, so I'm leaving that. I'm not solving that because it could, you'll have to spend a lot of time. And actually, I've gone through these options and they are kind of confusing, especially this one and that one. So I'm leaving that. Third one. A rectangular tray of 30 centimeter into 60 centimeter size is used for baking circular biscuits. So you have a 60 and a 30 centimeter tray to make circular biscuits. The diameter of each biscuit is 3 centimeter before baking. So diameter meaning this is 3 centimeter before baking, which increases by 10% on baking. So 3 centimeters the diameter, and that diameter increases by 10%, so it becomes 3.3 centimeters. Okay, 10% of 3 is 0.3. So this is my diameter. That means this is after baking becomes 3.3. Now the question is, what is the maximum number of biscuits that can be baked in the tray such that the base of each biscuit is in contact with the tray? So I've drawn it such that the base is in contact with the tray. Now remember, in this question, if you simply multiply 60 and 30 and divide it by the area of one such circle with a diameter of 3.3, yeah, then what will happen is you are including this red color region also. Uh, um, you're including in the sense what is happening is that if I were to just show you with a couple of circles touching each other 3.3 like that, then this red color region, yeah, they get added to form another circle. So you might end up getting more circles if you simply divide it by pi r square. That way you'll get more number of biscuits than the actual number of biscuits which should be there. So this idea is wrong. You cannot follow this. So then you might think, let me use another color. That let me say I'm using pink color where I am considering a square region like that, a square region where the side is 3.3 and 3.3. So that way you will say, okay, then I'll simply take a square, 60 into 30, I'll divide it by 3.3 square. Now this time what you'll get is, you'll understand that this 3.3 on this side, 30 divided by 3.3 is not going to give you an exact number. Neither on this side, 60 divided by 3.3 is not giving you an exact number, right? It'll give you a mixed fraction number. So even this will not exactly give you an answer, right? It will give you a near about answer, but not an exact. See, let's calculate. 60 divided by 16 to 30, and just make sure all the units are in centimeters. 60 into 30 divided by 3.3 square. It gives me 165. So 165, you might say, okay, 162. Yeah, 162 point, I'm getting 162.289. So you'll say 162.289. So 162 should be my answer. But wait a minute, let's double check the whole thing if it's correct. Yeah. So the actual way of solving this question is that it's a square. So 60 divided by 3.3. Okay, if you divide 60 by 3.3, then you get 18.18. So the idea out here is only consider the quotient. Okay. Similarly, 30 divided by 3.3, you get 9.09. And so only consider the quotient. And those quotients is a technique to solve such a question. Yeah. To get your number of biscuits. Because anything remainder, yeah, like obviously 3.3 times 10 is 33. So it will go up to 9. So that also could be another, you know, thought process that you could have used, that you could have got 9 this way, yeah, 9 this way, and therefore 3.3 times 20 is 66. So maybe 18 or 19 this way, you know what I mean? But this is what I'm getting, and this is what I'm getting. So this is a calculated one which I'm getting. I'm sorry, 18 and 18, 18 and 9. I'm getting a mathematically correct one. This you would have used your thinking power. So you could have ended up with 18 or 19. So extra math calculation. So when you do 18 times 9, that's nothing but 18 times 10 minus 18, which is 180 minus 18, 162. So yeah, this is the answer. So this would have probably given you the answer, because the answer I got was 1800 divided by 3.3 square, 165. So 165 is closer to 162. You would have got the answer, but it would yet not give you a confident answer. Another good question, I would say. Okay, question number 4. In how many distinct ways can 128 identical marbles be arranged in a complete rectangular grid? Disregard the orientation of the grid. Okay. So when you say disregard the orientation of the grid, they just simply mean that, okay, I can have 1, 2, 3, and 4. Yeah. So I can get, 128 by 2 is 64. 64 by 2 is 32. So 32 times 4 gives me 128. So this is one orientation. I can have 64 by 2, right? Two rows. 128 like that. Yeah. So there are 128, 64 marbles like this, 64 marbles like this. So two rows into one column. I could have one, two, three, 4 rows into one column. So this would be like, 32 into 4. So they are asking, in how many distinct ways can 128 identical marbles be arranged in a complete rectangular grid? So then you have to sit and do the math. So there will be 128 like this and one like this. So 1 into 128. So instead of doing all that, simply do your 7th standard math. And this will obviously give you 2 to the power 7 in a way. Yeah. 1, 2, 3, 4, 5, 6, 7. So we know that 1 into 128 is one way you can get one of the grids. 2 into 64 is another. 3 doesn't come in the picture because there are no 3's out here. So 4 will come. 4 into 32. Will 6 come? No. 8 will come. Okay. So 8 into 16 will come. And then after 8 comes 16, because none of the numbers, even numbers 10, 12 will come in the picture. This does not give you a multiple of 12 anywhere. So then if 16 comes, then 16 into 8 is already considered. So there are 4 distinct ways. That's your answer. Okay. So yeah, sometimes the questions framed framed in a manner that becomes difficult for us to comprehend what exactly they are asking. So practice more questions. That's all I can say. And the last question for this video, how many three-digit numbers exist whose first and last digits add up to 9? So you have three-digit numbers. Now remember 100, 101, 102, 103. These all three-digit numbers begin with a non-zero digit. So zero cannot be coming here. Okay. So how many three-digit numbers exist whose first and last digits add up to 9? So remember, you can have three digits where the digits repeat, like 811, 722, right? It could be 333, but then the first and last digit should add up to 9. So now, in this situation, let's understand which digits give you a sum of 9. Okay, they're countable. So no need to use this permutation method. Yeah. So 90 is the tricky one which comes in the picture. 09 will not come. So if you start with 0 and then 1, so I've got my 1 combination, I've got my 2 combination, I've got my 3 combination, 4 combination, 5 goes with the 4, 6 goes with the 3, 7 goes with the 2, 8 goes with the 1, and 9 goes with the 0. You cannot have a 09. So now these two numbers are fixed. This middle number can take any of the 10 digits, right? So in a way, this becomes one number and 10 out here. So I've got 10 three-digit numbers. Similarly, I'll have 10 digit three-digit numbers out here, 1, 10, and 10, because this one remained, this one is fixed 4 and fixed 5. Understood? Yeah. And similarly, I'll have, this is 20, and then 20 here, 20 here, 20 here, and this one you gotta be careful. This will have 10 options, so it'll be 1, 10, 1, only 10 out here, because you can't have 0, 10, 9 case. Okay, so therefore 80, this is 60, and this is 20 as well, and not 10. So you have 90 three-digit numbers that exist where the first and the last digits add up to 9. Another good question. So that's it. We'll stop here, and I'll continue with the remaining questions 6 to 10 in my next video. Thank you. And like I always say, if you have doubts, send me your questions on my email, friendlyspider@gmail.com. Yeah. Thank you.